Welcome, welcome. Today we're going to talk about one of the pages from the section of work that was assigned for Wednesday, March 18th through Friday, March 20th. These were not intended to be finished in a single day, therefore I will not be posting all of the pages at once as a review. Instead, I will be posting one page per day, and Friday I will be covering multiple pages. So, for number 1, it gives us this little example to work from, and it asks what part of the formula represents the area of the base of the container. So if we look at our container, our base, well, that would be the flat bit that we can't see all of. That would be, if we picture the back of that square, it's going to look a lot like the top shape. So this is what makes up my base. The formula we would use to represent that would be 4 times 2, the length times the width. So the base should equal length times width. Use your answer for problem 1 to write another formula for finding the volume of a rectangular prism. Instead of doing length times width times height, you could simply replace the length and the width with a base, or area of the base, represented with a capital B. For number 3, it says, use the new formula to find the volume of a container that is 6 feet long, 5 feet wide, and 7 feet high. Well, the area of our base is going to be my length times width. 6 times 5. 6 times 5, my area of the base, should give me 30 square feet. My volume then is going to be my base, which we just found to be 30, times my height, which for this problem is going to be 7. We now have 30 times 7. 30 times 7 should be 210 cubic feet. Number 4 says, if you know the volume of a rectangular prism and you know the area of the base, how can you find the height? Well, if we know we have volume, and we know that it equals the area of the base times the height, and then we know, let's just give an example, let's say volume was 20, and we know the area of the base would be, we'll just say 2, we don't know the height. Here's my example problem. So to solve this, we would isolate the variable h by using inverse operations. That's a fancy schmancy way of saying we're going to divide both sides by 2, and we're going to get rid of my base, so that way my height will equal one answer, and that will give me an answer. Moving on to number 5. Some sewing supplies were stored in a container that is 5 inches tall, 7 inches wide, and 12 inches long. Label the picture of the box with its dimensions. Everyone kind of has their own way. I'm partial to calling this front line the width, but most people tend to call this the length. So we're going to label this the length, 12. It does help that in this case 12 is the longest number, and 12 does appear to be, this line does appear to be the longest line. The shortest line appears to be the height, which matches what we find here, 5. And my width would be 7, a line that is longer than the height, but not so long as my initial value. B says what is the volume, and it asks to show our work. To show our work, we're simply going to start by writing the formula that we're using, and then we will substitute each value. My length, which is 12, my width, which is 7, and my height, which is 5. Considering that this is calculator active, this is all of the work we really have to show for this part. The key here is allowing your teacher or yourself to see what you have done for the problem to know if you followed the steps correctly. For this problem, we got 12 times 7 times 5, which is 420 inches cubed. For number 6, it says the base of a rectangular prism is 40 centimeters long and 5 centimeters wide. It says that the height is 2 centimeters. And it says to write two different equations that represent the volume of the prism. Well, we know volume is length times width times height, and we know that volume is base times height. So, length width height would be 40 times 5 times 2. There's one equation. My second equation would be if I have already done length times width, 40 times 5. 40 times 5 is 200 times the height, which is 2. These two values should give you the same answer. Number 7, it says that the volume of this prism is 84 cubic yards, and it wants to know the height of this prism. So we have volume equals length times width times height. We have the volume this time, which is 84. We have the length and the width, which is 7 times 4. We lack the height. So, for starters, for this problem, we're going to begin by combining my like terms. We can combine that 7 and 4 to get 28. So we have 28 times h equals 84. After we have done that step, we can isolate my variable by using an inverse operation. The opposite of multiplying by 28 would be dividing by 28. So 28 divided by 28 will just equal 1h. So my height equals 84 divided by 28. I hit times. My height is going to be 3 yards. That's it. You don't have to specifically write out 84 divided by 3. You don't have to write out 7 times 4. There is an obvious amount that I expect you to do in your head or to expect you not to write, and those would be them. Number 8, Sean's teacher said that the volume of a rectangular prism is 64 cubic centimeters. Sean says that that is enough information to already know what the width is, and is this correct? If not, explain why. Otherwise, give the width and explain your thinking. Well, okay. So Sean's teacher says the volume is 64. So volume equals length, width, and height. The teacher says 64 equals length times width times height. Sean says he knows for sure how to find the width. I'm going to disagree. Sean is incorrect. The width can, don't know why I put a comma there, it can be a specific number, but unless we also know what length and width and height are, we can't guarantee what that is. For all we know, width is 64 and length and h are both 1. That would be 1 times 64 times 1, which is 64. We could also have that length is 2, width is 32, so 2 times 32, which is 64, times height, which could be 1. Again, the answer would be 64. But there is no guarantee. There is no guarantee that width is a specific number. At least not yet. This is all for the first page. I will not be doing all of the pages all at once. I will only be doing one section at a time, as this assignment was intended to be broken up amongst multiple days. With the past couple of times we have done problems from the orange workbook, I do expect you to be using complete sentences like this, and when it asks you to show your work, I do want you to be taking the time to write out the equations that you are using. If nothing else, write how the equation should be set up at the beginning of each problem, so that way I know which formula you are using and can correct you if you are using the wrong one. That is it for page 1. Page 2 coming soon.